So this is amazing because you guys are like so much on time. I have never been in a conference where it starts on a second. I was presenting in India where everybody was excited about my talk because, oh, you know, we have one female speaker somewhere in India, somebody from Russia. Of course, everybody wants to go and listen, even if you don't care about HTML5. That's what I was talking about 2 years ago. I get into the room, and there are 8 people. It's like, I thought everybody was excited. Everybody was asking me about it. Well, 15 minutes later, the room was full, and people were standing. There was like no place to sit. It was just Indian time. So thank you for being on time. All right, so yes, I'm a senior security consultant at Cigital. I've been there for more than 4 years, 4.5. Before that, I was a developer, working on web applications, working in the game industry. I love that. However, I love consulting even more now. And yep, in my free time, I not only break out of handcuffs, but I do ballroom dancing. So there is proof. So we're going to talk about content security policy, and we're going to answer some of these questions. So what it is, why do we need it, and as Michael said, introducing me, well, we needed to fix cross-site scripting because that has been out for more than 10 years, and every year in a WASP top 10, it is at least in the top 3. It's like number 1 or number 2, like right now. So content security policy is a new way to fix this old problem that has been following us for years and years and years. And we're going to look at how it is enforced, how it is configured, what are the problems with CSP when we implement it, and what are the improvements? So we have CSP1 came out about a year ago, and CSP 1.1, so we're coming out with a new version, trying to fix some of the problems that prohibit us from using it fully in the existing web applications. And then if you have more questions, we're going to talk about more questions. So cross-site scripting, right? You all know what it is, and when we talk about it, usually we talk about 2 types. We talk about our reflected cross-site scripting, and we talk about stored cross-site scripting. Reflected when the input is reflected right away in the request, stored when it's in the database. Well, now, from like the last 3-4 years, we now have this new beast that's called DOM-based cross-site scripting. So what is DOM-based cross-site scripting? The previous 2 types were always, the input was always going through the server. So that's why when we were fixing it, we said, do input validation. Where? On the server, right? Don't trust the client. Do everything on the server. Do output encoding. Where? On the server. All our solutions that we're using these days have to be on the server. Well, DOM-based cross-site scripting happens completely in your browser. It doesn't go to the server. Sometimes the payload can actually travel to the server, but it's not, the page is not created with that executed JavaScript on the server. It is created later in the browser after the JavaScript parses it, manipulates the page. You know, with all the dynamic JavaScript that we have, that's happening on the server. On the client, right? So our traditional solutions are not going to work there. They're not going to protect us. We can do input validation on the client as well for these specific places where we're using dynamic JavaScript, where we're taking input from the user, parsing it with JavaScript, and then modifying the page and writing it out on the page. Yes, we can do input validation there. That's a valid solution. We can also do output encoding within JavaScript. However, these things are not very trivial. So, I mean, you should definitely do that, but it ain't going away. So DOM-based is still there, and it's rampant because we don't have the tools to fix it. The other thing is that if you're using web application firewall that's catching, you know, some of the payload, some of the low-hanging fruit, again, since this payload is not going to the server, your WAF is not going to help you. That's it. So what do we do with it? One of the solutions is content security policy, right? But before we start talking about how it's working, we will look at the ways how we can exploit XSS. So there are kind of 3 main ways, right? So here is your vulnerable server-side Java code, JSP code, right? You have your parameter S, and you write it out into the response page without any validation. And the input here would be inline JavaScript, right? So we have our script tags, alert, and we write it out. So that's going to be executed inline. The other way, the other attack, same attack but a different payload, could be where JavaScript will be loaded from a third-party site. So same code, but instead of doing our alert between the script tags, we load a file from attacker.com. OK, same kind of thing. Another place is our JavaScript code, and that's actually an example of DOM-based cross-site scripting, right? So we get some input from a user, from element which ID is parameter. We get some parameter. We get some JavaScript variable, concatenate that, eval that, call this function. And if the input is not legit, it's malicious, so we get, again, cross-site scripting, right? In this case, we don't have any request to the server. We don't have a response that's coming from the server. So we're just reading input from the web page, manipulating it, using eval, which is terrible. Every time you think of eval in JavaScript, I want you to think of evil, because eval is evil. However, I mean, you will hope your developers don't write this code. However, if you are using third-party JavaScript frameworks, well, you don't do probably code review on the whole framework, right? You're using jQuery, Node.js, whatnot, and some of them use eval. So you still may be vulnerable. So all these attacks happen because our browser doesn't know if that JavaScript in the page is legitimate or not. Did it come from your server, or was it injected by a cross-site scripting attack? If it's inline, or if it is third-party. And when you have your page, you're loading resources from all over the place, right? You have your forms, you have your plugins, you have some JavaScript that's inline, some JavaScript that's running in an iframe, loaded from some kind of third party, some JavaScript that's, some iframes that you trust, some iframes that you maybe don't trust. So you have that mix. And you hope that you don't have holes so nobody else can add more JavaScript there. What content security policy does is it establishes a policy that a browser enforces. And the policy says you can load these types of resources from these types of places. From nowhere, from everywhere, or from this whitelist. And the policy is created on the server, and it's passed as an HTTP header. And then the browser is the one who is enforcing it. So you have coordination between the server and the browser. And CSP has different resource directives, so you can specify where the scripts are coming from, where the fonts are coming from, iframes, CSS pages for style, images, media, object is your plugins, and then the connect source is for the web sockets. So we had a question in another lecture here how you can prevent attackers opening a WebSocket on your page and starting sending some information. So one of the things you can do is using connect source in this case. So this is what you do on your server. You set up an HTTP header, regardless of which web application server you're running. So in this case, we're setting a script source, and we're saying load scripts from self, so from myself, from the host of that page, and also from apis.google.com. By just setting this one line, you have done a lot of things. You disallowed all your inline scripts. You disallowed use of eval. And you limited the scripts that your application uses to just the scripts that are on your site or on the site that you have whitelisted. So let's look at some other examples here. Suppose we have the following content security policy, and we want to load an image from www.bbc.com. Will this be successful? Who thinks yes? Who thinks no? Okay, good. So we don't know. So in this case, an image is an image. And if we look at our policy, we have a default, and then we have image source wildcard. So this basically says you can load images from everywhere. So we can use wildcards in the CSP we can also use a directive that's called default source. So if you don't specify, like in this case, we don't specify anything for scripts or for fonts or for video, audio. That's the default for all the other types of resources, right? And say self and from, and we notice that we can also use wildcards for subdomains, start.mydomain.com. So this is a success. What about this one? We're trying to load a script from attacker.com, and we have the following policy. Who thinks this is going to be successful? Who thinks that the script will not be loaded? And why is that so? Default, right. So we have a default, and we say, yeah, default only from self or from mydomain.com. And the next one, we're trying to load CSS from wordpress.org with the following policy. Who thinks this will be successful? Who thinks that will not be successful? OK, that's kind of a tricky one, right? So we don't have default. We don't have the style source that is for CSS. Well, basically, if you don't specify default, by default is open. So if you don't specify default, your site can load resources from everywhere. So by default, it's star. So since we're not specifying default or style, this basically is a wildcard. So load from everywhere. And that actually shows the three most important directives that you need to set is your scripts, your iframes, and your objects, because otherwise you can exploit your page with the plugins, right? I would say that connect source is probably also very, very important. Well, connect source is limiting where the WebSockets can be open to, can talk to. If your script source is very limited, then the attacker doesn't have an opportunity to inject script, and then they obviously don't have an opportunity to open a WebSocket. So more protection here. So CSP is great because it's not only restricting your site, but it can also report what kind of problems, what kind of attacks your site is getting if you set it correctly, right? So what you can do is you can use this report URI directive and specify a URL that will be getting all the reports from the browsers. So your just custom parser that you want to use. And the browsers will send reports that look similar to that. The formats are slightly different between like Chrome and Mozilla and Internet Explorer, but more or less they all have the same parameters that says, here is the blocked URI, so this is where this malicious script was trying to be executed in your page. In this case, it's from evil.example.com, evil.js. Here is the policy that was violated, the violated directive, so that violated your script source. And here is the original policy. That is what you have in your script source policy. And this is great because it also gives you a tool for monitoring for what kind of attacks are happening on your site. And they may not be just the attacks. It may be some script that some developer included, and you forgot to include that in the content security policy, right? Or you had some third-party component embedded, and that third-party component is actually pulling resources, fonts, styles, images from somewhere else. So you're going to see all of that in your reports. And the other thing that you can do is you can use the policy in the report-only mode. So one of the problems with content security policy is that once you set that policy, it is very restrictive. And as I said, if your developers are loading some resources from some other third-party site that you weren't aware of, well, you enforce this policy, and these resources just stop loading. So half of your site just stops working, because half of the JavaScript is not loaded. Right? You don't want that to happen, especially in production, but even in testing environment. So what you can do is you can use report-only policy, which is similar, sets all the same directives. You set your report URI where the reports will be going, and it will capture the requests that are not in your policy, all the violations, and it will send your reports of the violations, but it will not enforce the policy in the browser. So your site will still work. So this is just for monitoring that this is when you start using the CSP. It's like, okay, what if I use this policy? What's going to happen? Oh, all my images will stop loading because they're loading from some site. So let's add this site now. What's going to happen next? Oh, my fonts will stop loading because they're loading from somewhere else. And you can gradually add these resources to your existing policy, because you can use them together. So you can say, my content security policy for now is quite open, right? I would say, maybe you would say default source is star, or in this case it's pretty restrictive yourself and from google.com. And then the report only policy is more restrictive, so you will test it and see which resources need to be added, which sources need to be added to your real policy. Well, as we said, one of the things that protects us from cross-site scripting and that CSP does by default is that it disallows all inline JavaScript. Sounds good, but when you think about your web applications, they all have inline JavaScript, and it's not that easy to remove it. You say, well, okay, inline JavaScript. So we have this sample page. So we have our script tags, and there are a couple functions in between the script tags. So we're going to create a separate JavaScript file, pull this data, set it into a separate JavaScript file. Well, your inline JavaScript is your event handlers as well. So now you need to pull out all your event handlers out of your JavaScript. So in this case, we have our onload event for the body, and then we have a button that has an onClick event. So what we can do is, in our JavaScript, we create an event listener for the document for the DOM content loaded event. So when the content of the DOM is loaded, we're going to fire this function. And in this function, we're going to go through all the elements in the page. In this case, we just have one button. So we're going to go find our button and add a click event to that button. And then we call our init function that needs to be called on the onload. But if you have a large page with a ton of different elements and you have your heavy JavaScript framework, pulling out all that JavaScript is not a trivial task. So ideally, in the result, you will get that. Your HTML page goes back to 1998, when there was no JavaScript. Just the static HTML, and we have one link to a script, source script, and this is our external JavaScript. Well, it's on the server, but it's not within the HTML page. So that's ideal world. And that's what CSP1 provided for us. And right now it is supported by almost all the browsers. You can see the list here. Some of them, like Internet Explorer, is providing partial support, so you have to have an X content security header with the X prefix. Hopefully they will remove it soon. The one that doesn't support it yet is like Opera Mini, Opera for mobile devices. But all the other browsers support it for desktops and for mobile devices. And here's some data. So this is from 2013, so it's a little bit, not completely contemporary. That's Verico did this research of 1 million websites that only 200 of them, 269, used content security policy in the final version, right? Without any prefixes, without any browser-specific prefixes. And then a little bit more used the XCSP, which is supported by IE, and a little bit more used WebKit, which is not used anymore by Safari. So now they're also moved to CSP. So the adoption rate is small, and you can see why it is small, right? Because it's not trivial to use it. However, even from those 300, 500 sites that try to use CSP, almost the same amount of them used it in a wrong way, because CSP has two more directives. One is called unsafe eval, and another is called unsafe inline. So guess what these directives allow you to do? They allow you to do to use eval and allow you to use inline JavaScript. So you apply your CSP, you look at your website, you realize it crashes, you realize that you're not going to remove all the JavaScript within the next month, and you have a release. And what you do, you just say, just allow unsafe inline for now. Using these two basically removes your CSP policy protection at all. Because what are you protecting from yourself? You're just allowed, again, all your cross-site scripting, all your inline, and all your eval stuff. So there has to be a better way to do that. I mean, for new development, you can probably start writing JavaScript differently and just write it in a separate file and change the minds of your developers, because this is a complete switch in your head, right? So CSP 1.1 is coming out. It's right now, I think it's a candidate state in the W3C standards. So they came out with two solutions. And one of them is using a nonce source directive, and another one is using hash source directive. And then they're also suggested to use CSP not inside the HTTP headers, but inside a meta tag as an option, which actually opens its own can of worms, because now if you can inject something in the page, you can inject a different meta tag and just change a policy. So that's a little bit different. So what is a nonce? We like nonces in software security, right? We like them for protocols. We like them for cross-site request forgery protection. Just add a nonce. So basically, all the script that you have, that inline script that is a legitimate inline script, you add a nonce parameter, you generate some hash value that is hard to predict, hard to guess, and you add it to your CSP directive. You say, execute all script sources that are coming from self and that also contain this nonce. So obviously, you want to regenerate this nonce every time the user loads the page. Otherwise, the attacker can just grab the nonce and inject a script with that nonce, previously known. However, a common solution, for developers, an easy solution to do that, well, if you're from Java world, for example, right? I'm just going to add a filter or an interceptor, and I'll take response, and all the JavaScript that it has, I'm just going to stick nonces there. Any problem with that? So if you have cross-site scripting, just old style reflected cross-site scripting, that passes some input to your server, the input is not validated, the response is created with the attacker's JavaScript injected. And after the response is created with the attacker's JavaScript, you add a nonce to it, because you add a nonce to every JavaScript. So it doesn't protect you at all, right? A better way to do it is to add these nonces to your template, if you use Vue templates. So before adding everything from the response, you first take whatever hard-coded JavaScript you have and add a nonce there. And only then you add whatever was coming from the response. So it's possible. Again, it's not trivial. It still requires work. Another question is, will the nonce directive prevent us from DOM-based cross-site scripting that is dynamically generated in the browser? And everybody fell asleep. No. So why do you think no?
Because you've already set the source. So if you're dynamically generating in your source, it's going to work.
Right. So you already have your snippet, your inline snippet with a nonce. And suppose you have an eval in there or something else, or document.write, and the attacker just writes more JavaScript in the same block. Well, this block was already approved by the nonce that you set, right? So again, doesn't protect us 100%. So then we have another solution. We have a hash source directive. So we like our tokens. Another thing we like in security, hashes, right? So let's take that JavaScript, that legit JavaScript that you generated, hash it, and add the hash to the policy. So then the browser loads the page, picks up every JavaScript, hashes every piece of JavaScript, every block, and compares the hashes with whatever you provided in the content security policy. And then your CSP will look even crazier because you will say, okay, we have default source, and then we have a script source, and then in the hash you would specify I'm using this algorithm, and here's the hash, and somewhere in there, like we have here's another hash, and if you have 30 different pieces of JavaScript, you have 30 different hashes for each page, and you have to regenerate them, right? So it's possible. It's a solution. It's not trivial, but that thing, if you apply it, if it works for your application, then you're not going to miss that other place where you still have cross-site scripting. Because that's the problem that we had is, we fixed cross-site scripting on these 10 pages, and we have one page where we forgot to fix it because this is a page that displays an error message. Who cares about error message, right? In this case, you specify a policy for your site. I mean, you can specify it per page as well. But in general, if you specify it, if you don't include your inline, unsafe inline, so nothing will get executed. And one more thing I wanted to say is there are some tools that help you create a policy, that help you test a policy, that help you kind of monitor the reports that you are getting. But unfortunately, there are no tools that will help you remove your JavaScript from your pages, right? It would be nice if you could take your application, dump it in some software, click a button, and then you get, oh, this is just HTML, and this is all JavaScript, and done. Unfortunately, JavaScript is a very complicated language, very flexible, and we cannot do source code analysis, automated good source code analysis on JavaScript because it's an interpreted language. Same kind of thing here. But this is definitely where we are going. So CSP 1.1, I don't know if I said that somewhere. It is supported right now by Firefox and Mozilla, Firefox and Chrome. So not by all browsers yet. But this is definitely the direction where we are going with the new protections for cross-site scripting. And that's all that I had for today. So I'm open to questions.
Hashing the inline script, is it actually checking the hash against the script as it executes, or is that just a unique marker for that block?
As the page loads.
Okay.
As the page loads, takes the script, hashes it with whatever algorithm you specify.
Could you then potentially still inject new code into that script block and execute it?
So you would inject the script, but the hash will not match, right?
But is it actually checking that map as it executes?
After it edit. I'm guessing yes. I mean, that would depend on the browser.
Yeah.
So
yeah.
once the code has been modified, then yes, you need to regenerate the hash.
Okay, cool, thanks.
Question?
Here in the front row.
Yeah, of course, about hashes as well. So how do we generate all this? Is it like any kind of tool that would allow us to generate it? Should we use like something like JSP on server to do that? How would we usually do that?
Yeah, so there is no one tool. If I remember correctly, so if you look up Neil Matatal, he's doing some open source development, and he wrote like a proof of concept that this is doable, and he has like a JavaScript that generates that. But there is no established solution yet.
If this is like JavaScript, which generates the hash itself, can it be manipulated by an attacker, the script itself?
So you generate your hash on the server, right? Because your hash is generated on the server. The hash on the client side is generated by the browser.
Well, thank you very much. It's been a pleasure and an honor.
Thank you.